we are going to talk about DID and smart contract wallets and how you can build a better user experience for a better Web3.
And this is Homie from Next.ID. So this is with our this is our partnership, like case studies. Hope you guys like it, and we will just introduce more about how you can use Next.ID to integrate with your wallet project.
So this is outlines of what we're going to talk about today. So first one is we're going to demonstrate how to use RelationService, one of the main services from Next.ID, to help you improve address lookup, which is the common things you do when sending transactions and doing transfers in wallets. Second synergy is going to be about like how we think it's very important to use a contract account, not an EOA accounts, as the foundation of your DIDs, and we're going to go into why that's extremely important. Third one challenge is going to be about like some compatibility challenge between smart contract wallets and protocols like Next.IDs and how to overcome it. Right. Okay. So first one, right? RelationService boost token transfer. So yeah, we're gonna start with a question. So compared to like when you're actually making transfer in Web2, right? Like Venmo's, PayPal's, Zelle, doesn't matter what you use. You know, compared to that, right? How many times you check when you try to transfer something in Web3, right? Like, come guesses. How many times you usually check, I don't know, address, tokens, whatever, right? Like I personally usually check something like 5 times at least, because one time like I sent some things through Coinbase on the wrong chain and it just swallowed my $5,000 without giving me a hiccup, right? So, this is a pretty common like user experience problem in Web3, and we're going to talk a little bit about like exactly why that's the case, right? So here's kind of like pretty commonly used wallets. On the left is kind of MetaMask, and on the right is supposedly better user experience wallet, Rainbow, right? So both are like actually still pretty scary to use. And so for example, like when you're trying to send a transaction to someone, right? Usually like we do like for someone like with EAS, that's probably a little bit better, right? But for someone with the address, you usually just copy paste it and check how many times like if that's the right address, because there's kind of like no safety rail guard, and there's no other information beyond the address that's kind of showing up here, right? So we're actually going to why do you not feel that anxiety when transferring money in Web2, right? So it's actually a very intentional user experience design, and so we're going to use Zelle as an example, right? How many of you guys use Zelle in real life? Oh, good. So if you remember, right, like I'm using Capital One, but you guys might be a little bit different. So when you're actually like sending some people money in Zelle, right, you're putting their like phone numbers, maybe email address. It's actually going to remind you like, okay, so this is a person signed up as, for me, right, George, right? So it's going to actually give you that additional piece of information for you to actually double check and confirm, and that additional piece of information, in this case, comes from the KYC you do at the bank, right? So that's the piece of information that's going to show up, and that's going to give you the peace of mind of, okay, you're actually sending it to the right person. So you don't have to double check, okay, like if I type in the wrong phone number or not, it's going to give you the double check, right? And so we can talk about like essentially like how Next.ID actually enables that and give you that peace of mind as well in Web3.
So this part is showing how Next.ID avatar like interact with all of your Web2 social accounts and your on-chain wallets. Like for example, this is this is for EC, and the left side is his Ethereum wallet, and the right side is his Web2 social accounts like Twitter and Facebook. So this is a one-time signature. So once you just put you just create some proof post. This is a public key, and the signature will just return back to the avatar, and everything will just combine together, and you will be ready to use it. So this is just a one-time. This is just a one-time solution. You will never need to like sign again with this. Once this is also this is a publicly verifiable solution, and this is a completely using cryptographically binding solution, and that is why we think this is a better way than OAuth, and this is a more decentralized solution. You can just directly combine everything together. Then you don't need to double check with your wallets in the future. Yeah.
All right. Thanks a lot for that. Okay, so like just a reminder of like how that's kind of relates to like the previous Zelle example we were talking about. So in the Zelle, like it's going to show you like the name of the person you're transferring to, because on the back end, there is like a KYC, right? Maybe this is your phone numbers, and that's your KYC actually real name, right? That's how it works. So here is kind of pretty similar, right? Except that like it's going to be like a relationship between your address, maybe your social handles, and also maybe your ENS address, right? So it's pretty similar, right? And so right now, so you can actually try this whole thing out in a website called web5.bios for people who actually have connected their identities using this protocol. Here's we're going to. I'm actually going to use one of the core contributor or founders of like Next.ID's Islu, his account. So for example, you know him maybe through Twitter, right? And you want to send him something. You just kind of find his Twitter handle. Use the Web5 bio website. Look it up. It's going to show you some of the related informations like ENS and some of the other related handles. Right. So right now you're kind of like doing this kind of by hand, but some more relations. But like in the future, essentially like this is kind of thing you can plug into the wallet, right? So you'll be able to kind of just type in his Twitter handles, right? And it's going to show you like, okay, that's like the person maybe you're interested in, that's his ENS. And it's kind of going to, just like what we talked about in the Dell example, right? It's going to kind of show you, okay, hey, this is the person you're trying to send a transfer to, right? Giving you that double check, the confirmation, so you don't have to worry about whether to send it to the right person, right? And if you go back to this kind of graph, so the binding actually not only binds the addresses, the identities together, just like some of the data providers, partners are going to talk about later today. They will actually also be able to retrieve all like transaction activities of that person associated with all the identities, right? So you will be able to, see okay whether you have what kind of transfer or activities you have done with certain parties on chain, and that's also going to enable you to have a similar experience as some Web2 payment solutions about like choosing receivers based on recent transaction activities, right? You've like interacted with these peoples, and you'll be able to, okay, I just want to send them again, based on these kind of on-chain activities and identity lookup.
Yeah, right. Also want to add on, if you guys try to use Web5.bio to just put in your own like ENS domain or any of your friends' ENS domain, you can just check the bindings, and we have the different data sources like Keybase, RS3, and many more. We'll just follow up. Also, we are compatible with UD, it's an unstoppable domain, and we will just bring more domain solution and resolve more domain in the future. So this is one of the solutions we want to just show you. This is just a front end demo, and for Unipass, they will just using this for their transaction. For their transaction product.
Yeah, right. Okay. So also going to talk about some UX challenges. Some of you guys like hacking UX for different kind of use cases. So like the idea here is actually a little bit tricky because it's permissionless, right? So you will be able to like put in whatever you want, and there isn't really a centralized authority stopping you, right? The difficulty here is that like in the case of Zelle, right, because it's a KYC, right? I put in your phone numbers, and you can't pretend that you're just someone else, right? That's kind of guaranteed by KYC, right? But here, like in this case, it's actually pretty straightforward and easy for me to pretend to be someone else, right? I just kind of bind myself with a Twitter that has somehow maybe I can just call myself Vitalik Buterin, right? No one's going to stop me from putting that name into my Twitter or my Twitter handle, right? So it's going to be a little bit difficult for you actually to make it serve the purpose you want. Because like you can also like bind different social identities into the same account, right? It's very likely that, for example, like maybe Afra has a Twitter, but he doesn't have a Reddit, right? I have a Reddit, and I pretend myself to be Afra in Reddit and bind it to my address, right? And then pretend that address belongs to Afra, right? So a lot of like UX challenges to actually make it work. So it's kind of interesting question to think about. I'm gonna talk about like second synergy. So it's kind of between like smart contract wallet and why we think that kind of should be the foundations for your decentralized ID, right? Let me actually talk a little bit about like what exactly is an avatar. So it's kind of pretty straightforward. It's just kind of like asymmetric key pairs using the 256K1 curve, which is exactly the same curve used by Ethereum. And the problem here is that just like with your wallet, right? If you lose your key, then you lose access to your wallet, and there's really no way for you to recover it, right? Whoever had your key will be able to do whatever you can with the wallet, and it's not like Web2, you will be able to actually change your password and you gain the control to your wallet, right? That's not really gonna happen. Right. So like with account abstraction, like the idea is actually pretty simple. You kind of separate the accounts into two parts, right? The control parts, the keys, and the actual account that's kind of holding your assets and your identities, right? And so the way we do at Unipass is like we use your emails as part of the recovery solutions, and everything's actually done on chain in the smart contract. So we are actually verifying the RSA signatures from your emails through a pretty ancient. Decades old not even Web2 web protocol called DKIM, so domain key identified mail. So you will be able to kind of verify who you are on chain using your email signature, right? So that way you will be able to kind of run social recoveries after you lose your keys. Okay, just kind of write emails, submit it on chain, prove who you are, and then replace your original lost or exposed keys to new keys, and you'll be able to use it as usual. So like in the case of like DIDs, if you kind of use this right as the foundations of your avatar or right on the graph, right at the center piece, right instead of a private key you can lose, right? So then you don't have to really worry about like how losing that or exposing that would be the end of your DID, right? So this is kind of another synergy.
Is it finished?
No. Oh, okay. I think we have enough time. So like we're gonna talk a little bit about the challenge between the current compatibility challenge between like smart contract wallet and protocols like Next.ID that's kind of based on cryptography solutions to kind of create these kind of binding relationships. It's not limited to Next.ID, so it's actually pretty common things. Also related to things like mirror XYZ, so a lot of compatibility challenges with smart contract or account abstraction. So yeah, going back to this graph, so essentially like how the way you bind like two identities together in the Next.ID protocol, right, is that you have the avatar, which is a cryptographic key, right, and maybe you have a Ethereum address, right? Then you can like create signed messages, and which is going to be okay. Maybe on the avatar, it could be about, hey, I want to bind my avatar to this Ethereum address, create a signature using your avatar's private keys, and then you can on the Ethereum address, you can kind of confirm by sending a message using your Ethereum key, right? So that's kind of how this kind of thing works. So the problem here is that like with your regular accounts, it's kind of externally owned accounts. So it's kind of like one account with its address or its ID that's kind of tightly coupled with actually an asymmetric key, right? The key is going to give you the way to sign it, and they're going to also give you the address, right? But that's not really like how smart contract wallet works. So smart contract wallet, the way it works is that like through the ERC-1271 standard, it's essentially defined a common interface for smart contract wallet to say, okay, this is how I send my message, this is how you verify my message, right? So you actually need to call something, a thing called is valid signature function, right, on the smart contract wallet to actually make the signature. So you can't just assume that like it's just a keys and it's specifically a K1 key, right? So that's not gonna work. Right, so this is usually like how, for EOA, how the signature and the verification works, right? You initiate transactions, go to the app, and the apps go to the EOA, see, oh, is this a valid signature? And the EOA say, oh, this is a valid one, and you execute transactions, right? But usually what happens is that like a lot of applications just assume that the entity they're interacting with are all like EOA wallets, that has a simple keys, signs, and verify transactions. So when they're trying to call that with a smart contract wallet, which of course doesn't have that, things are going to break, right? And but this is kind of pretty like simple interface fix, right? You just kind of change whatever signature verification method you were calling, usually ETHDSA, right? You just change it to this one. Like that's pretty straightforward. It's just kind of one line code of change. But the problem here is that like with Next.IDs, there is actually a need to kind of go back and verify that whether like two identities are still paired together, right? Across maybe after a week, so I don't know how it's done right now, because like there could be the case that some hacker just stole your wallets and then submitted a binding request to the Next.ID and then somehow bind your wallet to their account, right? And you don't want this kind of thing to be irreversible, right? So usually there is a need to kind of keep checking, right? But the problem with like contract account is that like the whole purpose is that like you want to be a decoupling between the account and the key, right? So the key can actually be changed. So the signature can also be changed, and what counts as a valid signature can be changed, right? So there is actually a need to say, okay, hey, this is the previous signatures, and I want to check like if it's still valid when maybe like after 10, 20 days it's signed when it's actually possible that the key is already switched, right? So there is actually a way to do it. Essentially, like there needs to be a change to the protocols that like you actually need to include the exact block number when the contract account made that transactions of signatures, and when you kind of verifying the signature later in time, so you just kind of go to an archive node and include that specific block numbers, and that will be able to help you verify the signature at the exact time it was made, even after the key is switched. So that way, like you will be able to kind of solve these kind of compatibility problems, right? So that's it. And we also like there's always a QR code at the end of the talk, right? So this is our like wallet demos, and you will be able to scan the code, have some fun with it. We're going to airdrop some like gas-free transaction tokens where you'll be able to use and make some gas-less transactions. Right? That's kind of one of the main benefits of smart contract wallet, right? Yeah, so that's it. Yeah, thanks everyone.